Okay. Hi everyone. Tell me if you can hear me. Okay, I suppose it works. So hi everyone, my name is Marcin. I'm COO of Warp Contracts as well as Redstone Oracles, and I'm a co-founder of ETH Warsaw. That happens in September in Poland. I invite all of you to come over there. Just a quick disclaimer before the presentation. I do not code. So if you ever heard of imposter syndrome, that kicks in really hard to me right now. So please do help me with this presentation. So I would like to start with a warm-up, like 3 simple questions that will help me to guide you through the presentation. So the first one is, who has ever heard of Arweave? Raise your hand, please, and keep it. Please keep it. Okay, then the second question, who has ever interacted with Arweave? So did a transaction, did some, okay? And who knows how it works under the hood? All right, good. So then the first slide is not going to be useless in this presentation, so let's kick in. So introducing Arweave. It's not Arwave, it's Arweave from weaving. It's quite a big misunderstanding many times at the very beginning. So it's a layer 1 blockchain that allows you to store data permanently, sustainably, and with a single upfront fee. So basically, I sometimes will check some data. So right now, the cost of 1 gigabyte storage on Arweave, which is a blockchain, varies between $2.50 to $5. Okay, way more than AWS, but in comparison to Ethereum, it's 1 million times more lower, right? And you can say, okay, compare it with IPFS, but IPFS stores data not permanently, but as you pay, as you keep on paying. But over here you have like 1 payment, and they use some, like the consensus mechanism called second proofs of random access for their consensus. I encourage you to read their yellow paper. Great read, I did it. I understood probably like 3% of it. But what struck me was like 200 years they claim they keep the data. And they are able to do that because of the diminishing cost of data storage, because of the devices like are getting more efficient. So first you have this affordable storage compared to generalistic chains. You have long-term availability guarantee, as I said, like 200 years. However, everything comes at a cost, right? So over here we have a really long block time that can go up to even like 20 minutes, which is crazy for the space. And the data indexing comes with huge issues. Okay, but one thing you need to understand is that many of you heard of Arweave or used Arweave, but for data storage only. So like inputting, either querying, right? So receiving the data. But you never probably thought about the contracts on Arweave, so like logic, adding logic to these transactions. And that's what we needed for Redstone. So Redstone was the original idea that we were developing as the company, and actually Redstone took part in the first batch of Arweave incubation program called OpenWeb Foundry, and we did it together with Kaif. I know they are going to have presentation over here with Fazila, and also with Spheron. Parashant is going to be over here as well presenting, so good to see the guys like developing their projects too. And right now, for Redstone, we needed not only Arweave storage transaction, but also some logic behind it. So let me quickly explain how Redstone works, just to give the context. So Redstone is an Oracle marketplace you can think of. On one end, you've got data providers, so like specialized companies that have data and would like to monetize it. On the other hand, you've got dApps that need to consume data, right? And Redstone is in the middle. So the data providers would put their data, push the data to our decentralized cache layer, so like long-term storage that is powered by distributed nodes over the globe together with Streamer network. Hi, Matthew from Streamer. He's going to have a presentation today too. And then on the other end, the dApps with their front end. Everything happens on Web 2 for now. With their front end, they would call this cache layer, fetch the data, and then only when there is an interaction with their dApp and the transaction is sent onto the blockchain, let's call it Ethereum, Celo, Avalanche, whatever, then to their call data of this transaction, this data package would be attached and sent onto the blockchain for use. And in this data package, you've got the data feed, so price feed usually, the signature of the data provider, together with the timestamp, right? So in short, that's how Redstone works. Why do I tell it to you? because we needed Arweave not only for storage, but also for logic behind it. Why? First, data access logic, so managing access and update rights. So for the data providers, we keep the registry of all the data providers on Arweave. So we would have to input it, but also be able to rewrite it up, right? I mean, the data providers would change, would go out, go in, so we need to change it over time. Secondly, the data integrity, so implementing our proprietary dispute resolution mechanism. So in case the data was tampered with, was incorrect, right? So then we have like a proprietary technology based on SmartWeave, which are the contracts on Arweave. And third, we also use Arweave for storage, just storage. So all the data feeds that are delivered to the data, to the DApp, is also stored on Arweave, because this data is used just for the context of a given transaction, and we keep it on Arweave for consistency, right? So we can retrieve it, like see how it worked before. So originally the contracts on Arweave were brought by the core team, and it was called SmartWeave, the protocol, but it was super inefficient, and we took it and basically optimized that and gave it the name Warp. But why the hell Warp? So there are two reasons. First, in waving, you've got warp and weft, so that gives you a fabric, right, like the weave. And then the second reason is Peter, the galaxy brain behind Warp contracts, loves Star Trek. I don't know whether you know this series. And over there, they had like something called warp speed, which is like this intergalactic speed. So we also wanted to emphasize that we want to bring SmartWeave the speed that it requires to be efficient. So this is simply how the original SmartWeave looked like. So look, it's a complicated concept, but to make it super easy, imagine that you decouple the data storage from the computing, right? So it's like decoupled. Usually on Ethereum and other chains, it's all together. So storing code and inputs on Arweave, everyone can evaluate current state. So everyone can just fetch the transactions that are relevant for a given smart contract and calculate the state. So how it happens? First, the source code and initial state is stored on Arweave. Then users writes inputs to the contract. Lastly, contract state is evaluated either on your local computer or you delegate it to someone else, like to the service that I'm going to talk about later. So 3 simple steps. And yeah, everything looks beautiful, but SmartWeave had real performance issues. Like it was taking 2 days to evaluate popular and complex contracts. And that's a real picture from the office of Kaif when they were trying to evaluate a couple of contracts. So hi to Kaif team. Unfortunately, they had to move to another chain with their logic, which is a huge pity. However, what we did, we were like, okay, hey, we had a really good example of their contracts there. They were super heavy and that they had problems with calculating. So with our Warp contracts implementations, we basically took them and did some tests, how much quicker it would be. So the improvement was like astronomical. You can see over here like just the mean and median, so it's in milliseconds instead of like hours that was happening with SmartWeave. So this contract has like 800 interactions, so it's a piece of cake. But let's go to a contract that has 93,000 interactions, so a huge one. It's still, we keep it like within 93,000 milliseconds. So it's just to show you that it's possible to increase the performance so that it's usable. You can see all of these contracts on one of our tools called Sonar. So if you type warp.sonar.cc, you're going to see all of these contracts. So let's come back to original SmartWeave. So how it worked, it was like many contracts would call data from Arweave and try to calculate it, which is inefficient because Arweave is not the best for querying, like from the very beginning. So what we did, first we created Warp Cache, which is kind of on a client that calculates the state so that the contracts wouldn't interact directly with Arweave, but first with the Warp Cache to optimize the querying, like ordering and the flow. And then we also added a gateway, which essentially what it does, it fetches only transactions from Arweave that are relevant for SmartWeave contracts. Because as I said in the beginning, you've got only the inputs that are the storage, but you also have the SmartWeave interactions. So gateway fetches only the SmartWeave interactions, leaving all of the just storage transactions there, and then it indexes it. And that's super crucial, right? Because later it's way easier to fetch it. So there are like 2 components over there, reducing the number of direct calls to the Arweave storage. But then you have the problem, all right, if you keep contracts outside of the network, how do you do like cross-contract calls, right? Like contracts interact with each other. So originally there was something called foreign calls protocol. So it was like an intermediary contract to register calls. So you've got two contracts. If they want to communicate with themselves, you had to create like the third contract and then the fourth contract and so on. Inefficient, right? So what we did, we created something that we call a predict and verify method. Put it simply, like, I don't know what's that, no clue, they sent it to me. But put it simply, look how Ethereum does the dry runs to calculate the amount of gas you require for the transaction. So this is what we do. We take the contract, we evaluate with a dry run how possibly it is that the contract will interact with another, and then when the interaction happens in the end, we check whether we had it with our dry run. I mean, it works. I mean, I can just tell it that. What else we added? So originally we were writing SmartReef contracts with either Java or JavaScript and TypeScript. And that's quite handy. However, it's not too secure and it has performance issues. So first we created something like the WebAssembly execution environment. So first we added the security because we used sandbox environment. Secondly, the speed is way more efficient to execute. Harder to write, but better to execute. And third, we had like multi-language support. So if you wanted to write your code in assembly scripts, Rust or Go, you could go with that, and that's way higher in efficiency, right? If you go for a long term, that works. Now, I told you about the problem with the block time, which can go up to 20 minutes. So for that, Bundler came on a white horse that we could use, right? So Bundler, what it does, it makes the promise of seeding the transactions into Arweave. So it's a kind of layer 2, you can call it. Sorry if I explain it wrongly. Later, Amelia, COO of Bundler, is going to tell more about it. But that was a perfect optimization for our Warp cache, so that we can just go to Bundler, trust them that they will seed the transactions to Arweave and don't care that much about this part. However, we added also a layer of sequencer between the user and the Bundler. Why? Just to give all the transactions a deterministic, predictable order, because before it wasn't possible. So basically we are kind of ordering all the transactions, and here is the trick. Many people say, hey, but the sequencer is centralized. You're taking care of how the transactions are ordered. True. Right now I don't have a perfect answer to that. However, we have the roadmap how to decentralize it and make it kind of blind. So this is on our roadmap, but right now it works beautifully. I mean, Accord, Pianity, Bundler, all the other projects built on Arweave use it, and they are very, very satisfied. So I told you that the state is calculated outside of blockchain. People would use it, would do it on their own machine. However, they can also delegate it to our distributed execution network. So basically, these are like sets of nodes that you can pay a small fee for them to calculate the state of the contract, and you just deal with the state of the contract at the very end. So it's a group of nodes listening to updates on a subnet of contracts. And this one is still, we're working on that. We have few of them, but there are some issues when it comes to communication between the nodes that we are going to use probably Cosmos SDK. But if you want to learn more, you can definitely go to our website and read. And now, let's go together with the transaction cycle. So imagine there is a smart contract interaction on Arweave. First what happens, the sequencer gives the order, fantastic. Then it goes to Bundler. So Bundler gives making sure that the seeding is there. By the way, this is on our website, so you can come back later to it. Our gateway takes the interactions from both Bundler and Arweave. It sends it to Evaluator, our SDK on your local machine, or you can delegate it to them, and then you have the state evaluated, right? Okay, so this was closer look, but don't have time. This is about, yeah, I'm running out of time, I believe. This is the communication layer between the nodes in the distributed execution network. For that, we would most likely use Tendermint SDK from Cosmos, but this is still R&D. Okay, so I'm missing one thing over there. There was this sonar. So basically, it's a kind of contracts explorer. So you can think of Ethereum Explorer, but for Arweave SmartReef contracts. We created it from the scratch. It's a really neat tool. But here, all of that can sound like magic. So you can go to academy.warp.cc and go step by step building your own first contract on Arweave. So what are the use cases that you can bring with Warp? So first, Web3 gaming. This is a huge opportunity there because usually you just store NFTs on Arweave. Why should you just store it when you can bring also logic on the chain natively? So card trading games, token-based strategies games, gaming with NFTs. DeFi as well, because right now we recently, like a week ago, released a sample DEX, like how a DEX could work with that, or NFT-based financial products. All NFTs almost right now, maybe not all, but majority of them are stored on Arweave anyway. Social apps, really like no-brainer, social networks, messaging boards, community services, and naturally hosting the UI you can do on Arweave using, for example, Spheron that is going to do the presentation later. So thank you very much. That was a quick brief of Warp contracts. If you want to learn more about Warp contracts or Redstone, catch me after the presentation. This is our website, warp.cc. I invite you to our Discord. Warp contracts is our Twitter. And you have academy.warp.cc to learn more. I don't know whether we have time for questions. No questions. OK. So thank you a lot. And yeah.